again, Year 5 and Year 6, and welcome back to this week's Key Stage 2 Science Learning Journey. Now, this is the second video in this learning journey, so if you've not watched the first video, which is called Plan, then I do suggest you go back and do that so you've got a greater understanding of what we're doing, and it will also give you guidance on how to make your rocket and how to prepare for your experiment, which you're going to carry out today. So we're going to start with a recap, and then we're going to have some new learning, and then finally your experiment to complete, and then some support on how to write up and present your lab report. So our outcomes by the end of the week are to conduct a scientific experiment and then to write up a lab report including a question, prediction, method, data and a conclusion. And some people will turn this into a learning journey, which includes all of the above, as well as posters of scientific explanations, a glossary, and their own research. Okay, so in the first video then, we started with our inquiry question, which is, how does the number of fins impact the distance a rocket travels? And after identifying the keywords in the question, we decided we were trying to work out how the number of fins changes the distance that the rocket travels. And we were wondering if a rocket has a greater number of fins if it will travel further. And as part of this working scientifically and planning for our investigation, we needed to do or sort of have some scientific knowledge of the forces that impact rockets' travel. So we learnt about thrust, gravity and air resistance. So Year 5 and 6, what can you remember about those three forces? Pause the video now, go back to your work from earlier in the week, see if you can challenge yourself to be that explorer, to be somebody who seeks a challenge. Okay, so thrust then is the force that pushes or pulls an object into motion. In this case, a chemical reaction happens which creates a gas which thrusts the rocket up into the air. Gravity is the opposite force which pulls the rocket towards the centre of the Earth. And that gravity is the reason that objects fall to the ground. They are being pulled towards the centre of the Earth. Air resistance is the force of air pushing against something as it moves forward. So as the rocket is being thrusted into the air, air resistance will be pushing against it, trying to slow it down and stop it moving. Okay, in order to carry out an accurate experiment to answer our question, we are going to need to ensure that we carry out a fair test. Now, what is a fair test? A fair test is one where only one variable is changed, while all the other variables are controlled or kept the same. So, what do I mean by one variable is changed? Now, in our question, there is one thing that we're going to be changing. Can you spot what that one thing is that will change each time we do our experiment? Well done, it's the number of fins. That's the one thing or the variable that will change when we do our experiment. All the other variables are controlled. That means we're going to need to keep them the same. So when we carry out our experiment, which things will we need to control or keep the same? Pause the video now and have a think to yourself. When we carry out our experiment, we will need to control these variables. Where you are doing your experiment. So you need to do your experiment in the same place each time so that the forces remain the same. For example, if you do your experiment outside, where there is a greater air resistance, and then you do your next experiment inside, where there is less air resistance, then there will be a change, and it means you haven't controlled that variable or kept it the same. You'll need to use the same rocket each time, and the same sized fins. Remember, the only variable is the number of fins. So when you change the fins, they will need to be the same size. You will need to think and make sure that you blow to the same amount, so how hard or soft you blow. So if you are filling your lungs with a big deep breath, then you need to do that each time you fire your rocket. If you are only half filling your lungs and you're doing a softer blow, then you'll need to do that each time you blow or launch your rocket. You'll need to make sure the way that you're measuring remains the same. So you could use a tape measure or you could use your feet to measure, but however you do it, it needs to remain the same each time. So this brings us on to your first activity for today. So in your book or on a piece of paper, you're going to design a page which explains what a fair test is. And then you're going to explain how you will ensure your experiment is a fair test. You can use this video to help you. Don't forget that you can also include drawings and examples. Okay, it doesn't have to all be writing. When you've finished designing your page, please share it with Mrs. PA and myself on Class Dojo so that we can see how you're getting along. And then come back to this video because we're going to do our experiment next. Okay, welcome back everybody. Hopefully you have your rocket ready now and you have completed your page about a fair test. So a quick recap then. Our experiment is going to answer this question. How does the number of fins impact the distance a rocket travels? So we are thinking more fins might mean it travels further. Less fins, does it travel a smaller distance? Or is it the other way round? Do less fins mean a greater distance travelled? And more fins mean less distance is travelled? Our gateway is explorers, so we're looking to seek challenge and aspiring to be the best version of ourselves. So we're really looking, everybody, to be seeking challenge and working to the best of our ability. Now, as part of our plan, we're still on this part of the cycle, the plan, do, review cycle. As part of your plan, you'll need to write a hypothesis or a prediction. And this is where you say what you think is going to happen. You'll need to use your knowledge of forces to help you explain. I think the greater the number of fins, the further the rocket will travel because, in my opinion, if a rocket has less fins, it will travel further because there is less air resistance. Okay, so there are some sentence starters that you can use to help explain what you think is going to happen. Remember, we're trying to challenge ourselves, so do try to include your scientific knowledge. And there's some key words that you could use in your prediction or your hypothesis. You don't have to use them all. Challenge yourself to use one or two perhaps. Or if you're feeling particularly adventurous today, you could challenge yourself to use all of them. Air resistance, streamline, thrust, drag and gravity. Okay, year 5 and 6, it's time to pause the video again and to write your hypothesis and your prediction. When you've done that, please come back because we are about ready to start our experiment. Okay, welcome back then. Hopefully you have completed your page about a fair test and you've written a prediction, so what you think is going to happen. Now we're on to the do section of being of working scientifically. And that means we're going to carry out an experiment to answer our inquiry question. How does the number of fins impact the distance a rocket travels? So I've tried to create a diagram here for us. So we've got our straw rocket in the middle that you've created. Your thrust is going to be you blowing into the straw. How do you ensure that the thrust is controlled to ensure we have a fair test? What do you need to do each time? Excellent. So however much you blow, it needs to be the same each time. So if you do a big hard blow for the first launch, then you need to keep doing that each time you launch your rocket. You're going to need to measure then how far your rocket travels. And again, you can use a tape measure or you can use your feet to measure. When you're measuring, you're going to have to measure from where you're standing, so where your rocket started, to where it landed. And you find the cone on the end and measure it. Okay. You'll need to repeat that then 4 times because you want to find out, or at least 4 times I should say. You might even decide to put 5 fins on there or 6 fins on there. But you need to repeat at least 4 times, each time adding your fins on and measuring accurately. So how are you going to record your data? Now here is a table that I've created with the number of fins and the distance travelled. I've put centimetres here as my unit of measurement, but you could decide that metres is more appropriate. Or if you're measuring using your feet, then you are measuring in feet. Okay, before you start then, don't forget to consider those variables that you need to control to ensure that you have a fair test. Okay, good luck year 6 and year 5, sorry. Please do share your learning with Mrs. PA and myself on Class Dojo. I'm really interested to see what your data will tell us. When you've finished your experiment, you'll need to come back to this video because I'm going to talk you through how to write up your scientific lab report. Okay, so pause the video for now then, carry out your experiment and create your data table, and then come back to me when you are ready. Good luck everybody. Welcome back year 5 and year 6. So a quick recap of where we're up to today. We have reminded ourselves of the question and how we're going to answer it. We thought about our gateway and working scientifically. We've carried out our experiment and recorded our data, and now we're beginning to think about our science lab report. So our question is, how does the number of fins impact the distance a rocket travels? And we are being explorers, we're challenging ourselves, and we're aspiring to be the best versions of ourselves. We've planned our experiment and we are now at the do stage before moving on to the review on Friday. Now, one of your outcomes was the scientific experiment, which we've completed today. And then your second outcome, or part of that, sorry, was to create a science lab report, which includes your question, your prediction, your method, data, and a conclusion. So a science lab report then, I've got a success criteria here for you. And this could be done on one piece of paper or in your book. So at the top of your page, you'll have the question. How does the number of fins impact the distance a rocket travels? Underneath the question, you'll then have the subtitle or subheading, Introduction. And this is the part where you explain what you're investigating or what you're trying to find out. Once you've written your introduction, your next subheading or title will be hypothesis, or you might prefer to use the word prediction. And then you will write up neatly your prediction, not forgetting to use that conjunction because to explain your ideas using your scientific knowledge. Then underneath your hypothesis or prediction, you'll write the subheading or subtitle equipment, and this is where you list what you need. So you could use bullet points to do that, you could use numbers to list, or you could draw pictures with a caption. When you've done your equipment and you've listed that, underneath you're going to write the subheading method, and then you're going to write out step by step what you did. And that will need to be so clear that a stranger could pick up your method and know exactly how to do your experiment. You'll also need to include how you made your experiment a fair test. And then finally for today, you're going to need to draw your data table or your results table using your pencil and a ruler to present your final lot of data. Now, if you're feeling quite confident that you could go away and write your lab report now without any further assistance, then you can pause the video. If you do get stuck, come back to the video because what I'm going to do next is go through each of these steps slowly and carefully with you, giving you some hints and tips of what to write and how to complete each set. Okay, so at the top of your page then, you will write the question. And you might want to pause the video now and copy it in onto your paper or onto your book and underline it neatly with your ruler. Okay, so success criteria 2 was to write your introduction. And now it's time to use introduction to create your subheading. So you're going to write that under your question, introduction, and then underline it with your pencil and a ruler. Now, your introduction tells people a little bit more about your experiment. It explains what the point of your experiment is, why you're doing it, what you're trying to find out, and what you already know. Now, I've got some sentence starters here for you. So you could say, or you could write, I'm trying to find out how the number of fins on a rocket impacts the distance it travels. I am investigating how the number of fins impact the distance a rocket travels. I already know that air resistance can slow a rocket down. It is powered by thrust, so the thrust must be more powerful than the air resistance. Okay, I suggest now Year 5 and Year 6 that you pause the video and you take a moment to write your introduction, and then when you're ready you can come back. Okay, welcome back then. So on your piece of paper you've got the title at the top, which you've underlined neatly. Then you have written your introduction subheading and you've written your introduction underneath. And now it's time to write the next subheading, which is hypothesis or prediction. And then you're going to write up your prediction neatly. And you'll remember you wrote this before you did your experiment. So no changing it now, you've got your results. I know some of you are a bit sneaky like that. Okay, keep it as it was, but it's just your chance to write it up neatly. Don't forget, you're challenging yourself to be the best version of yourself. So do try and use the knowledge that you have about forces to explain your ideas. Okay, Year 5 and 6. So if you pause the video now, Write up your hypothesis and then come back when you're ready for the next step. Okay, so underneath your hypothesis or prediction, you're going to put the next subheading, which is equipment. And then you are going to list the equipment that you used. You might decide to use bullet points to list the equipment, like so. You might decide that you're going to draw a picture of the equipment, and then you're going to do a caption with the equipment listed underneath, and so on. Okay, it's up to you whether you do the writing or the drawing. We don't mind either way, year 6. Come back to the video when you're ready for the next part. Okay, the next part then to think about is the method. So underneath where you've listed your equipment, you'll need to write the subheading method and to underline it with your ruler. Now, the method is where you explain what you did and how you did it. You list the steps that you took to complete your experiment, and you explain what you did with the equipment. This is like a step-by-step guide for your experiment, and a stranger should be able to pick up your method and carry out the experiment. You'll also need to make sure that you explain how to keep it a fair test. And you may want to use that key scientific vocabulary, control variable. That's the thing we kept the same. Can you remember what that was? There was quite a few actually of those, wasn't there? And then we had the variable, which was the one that we changed, which was the amount of fins. Now I have got an example here for you to help you get started. So you may decide to list out your method step by step like this. So number 1, draw a square. Draw your triangles. It explains how to draw your triangles. Use your sticky tape to draw a circle and mark out a small piece of pie from it, and so on. You may decide, actually I don't want to do that much, I don't want to do the writing today. I'm going to draw a picture instead, and I'm going to draw a step-by-step picture diagram. If you are going to use pictures, don't forget to use captions as well to explain what is happening in each picture. Now, it's time to pause the video, year 5 and 6, and to write out your method. Come back when you've finished. Okay, so hopefully then you've just finished your method and you're ready now to think about your data or your results. So underneath your method, you're going to need to write the subheading, data or results, and underline it with your ruler and pencil. Then you'll need to write a short sentence which explains what you're showing. So for example, this table shows the number of fins the rocket had and how far each amount of fins travelled. So I've got my number of fins here, and then I'd have my distance that they travelled written in here. When you come to draw your table year 5 and 6, make sure you've used your ruler and a pencil, that you've got the headings at the top, including your unit of measurement. Some of you will want to be working really scientifically. Don't forget our Gateway as Explorers is all about challenge and perseverance. Some of you will want to be working scientifically and will want to create a graph to show your results. Now, if you create a graph, here's an example. I recommend that you do a line graph, as visually that's going to be the easiest thing to read. So on this axis, at the bottom, I've put the number of fins. And then up the side, I've put my scale. So I went up in 5s, but you'll need to look at your distance to know what your scale will be. I've got a title, and then I've drawn and plotted on my distance and how far each one travelled. If you'd like any help with that or guidance, you can message me on Class Dojo, or you can ask me on our live Zooms. Okay, it's time to create your data and results table. And then that will be the end of our video, and you should have completed your lab report for today. Okay, have a lovely day, everybody. Please, please, please send Mrs. PA and myself your learning. We're really keen to see how you're getting on and to be able to share the successes that you're having this week.